It's important to distinguish between the different types of errors you can encounter when you're programming. We've seen errors where the program won't even run because there's a syntax error or a compilation error. Here we'll see a different type of error where the program does compile and it does run. However, it doesn't do what we want it to do. So for example, this familiar program has a logic error in it. So I'm going to put in 5 and it says correct. And if I run it again and put another wrong answer, it still says correct. So putting in 2 actually says that it's incorrect when it should say correct. So if we look at the program, I made one little change to one of our previous examples, and I've changed it from this to this. This just says if the answer is not equal to 2, print out correct, otherwise print out incorrect. This is a mistake of the programmer, obviously, and we call this a logic error. Here we have a number of programs which you have a copy of and you can run as you're watching this video. What we're going to do is simulate what the computer is actually doing as it runs the program. We want to be able to follow through the program as the computer would do it when it's running the program. So to do that, we're just going to draw on our note here. And so the program starts on the first line, and after that it assigns a value to a variable called capital. It proceeds to the if statement and it checks to see if the capital is not equal to Toronto. It's true that it's not equal to Toronto because it's equal to Mississauga, and so it runs the contents of the if statement. Once it's done running the contents of the if statement, it continues after the if statement and says, thanks for playing. So you can try running that program yourself. Okay, in this example, we start off similarly. We come to the if statement. Is name equal to Kevin? Yes, so we run that. And because it's equal to Kevin, we're not going to run the else condition or option. We're going to just jump over that and continue after the whole if-else block. So we don't even visit these instructions. We don't execute these instructions. So same program, except that we've changed the value of the variable name to something that isn't Kevin. So because it's not Kevin, we're going to jump to the else, and we're going to run the contents of the else, and then we're going to carry on with the program. So you'll see that we've skipped over this line. Here we've got 2 variables, flavor and temperature, and it's saying if the flavor is sweet and the temperature is cold, or is hot rather, it'll run this. So that's not true. It's sweet, but it's not also hot. So it'll visit this, but it'll jump over to the next if statement because it's not running this. And it is true that flavor is sweet and temperature is cold, so it will run the contents of this if block. It'll run both of those instructions, and then it'll run the final instruction. So here we're prompting the user for their gender, and they enter an M, supposedly. There's no actual interactive input. We're just setting the gender to M. And so we're pretending someone's entered something. And so it says enter your age, and they supposedly enter 15. And then we come to here and it says, is gender M? Yes, it is. So we go inside the if statement and we find another if statement. Is the age less than 18? Yes, it is. We're going to print out boy. Now, because we've executed the if block, we're not going to execute the else block. And because we've executed this if block, we're not going to execute this else block. So we're going to jump all the way to this line. And that's the reason we're skipping all of this. Same program, different variables. Gender is F, age is 15. So gender is not M, so we're going to jump all the way over to the else and consider what's inside there. We find another if. Age is less than 18, so we're going to print out girl. Because we've done the if, we're not going to do the else. And that means we're done this whole block, and we can jump out to this final statement.